In this presentation, we're going to discuss the importance of engine maintenance and how it affects the performance of your diesel particulate filter. Through this presentation, we hope to provide you with the tools and information to increase the efficiency of your truck fleet as it pertains to the diesel particulate filter. The presentation will cover 8 important areas of interest: control systems definition, the typical standard practices that are used to confirm the engine's performance, engine problems that are not detectable by conventional methods used in most repair facilities or by the truck operator, engine tailpipe emission sensitivity, how minor engine changes can drastically affect emissions output, engine full maintenance schedule so you can confirm that your fleet is meeting the standards required by the DPF. In addition, we will discuss the importance of keeping good maintenance records. We will debate which maintenance items should be added or taken away to adjust your fleet-specific needs. And finally, we will inform you of the services that Emission Services Unlimited Incorporated performs. Over the past few years, since the introduction of retrofit diesel particulate filters, most fleet owners, operators, or mechanics have tried to separate the DPF from the engine. Essentially, they have treated the DPF as a foreign item on the truck. By doing so, the engine is treated as one complete system, and the DPF is treated as another control system. We must now begin to treat the engine and DPF as one control system. When we begin this thought process, it becomes much easier to diagnose the root cause of any DPF or engine issue. Many perceive the DPF as being problematic due to frequent onboard diagnostic lights illuminating. However, we must remember that prior to the retrofit DPF, we relied on the truck OBD or service engine soon light. Now the DPF has become the canary in the mine shaft. The DPF is much better at detecting engine problems than the old service engine soon light was. This is due to the fact that almost every engine problem or slight wear of the engine will increase tailpipe emissions. The DPF is now capturing all of those tailpipe emissions by the nature of its operation. It is important to point out that the most difficult part in being a retrofit emissions installer is determining the correct DPF for the application of interest. There are many makes, models, and types of DPFs available in the retrofit world these days. There are active systems that provide a higher regeneration rate to keep up with high SIP production engines, or we could call these dirty engines. There are also passive devices that are only intended for high temperature, low SIP production engines, also known as clean engines. You may have heard the term PIC, also known as pre-installation compatibility. This is a relatively new process that looks at the condition of the engine to verify which DPF will most effectively work with the engine truck application. PIC has been introduced and pushed forward by the Air and Resources Board due to the high number of misapplied DPFs since the inception of the various diesel retrofit programs. Before retrofit DPFs were considered commonplace, many engines were allowed to operate with substantial wear. There is a common misconception that the standard Air and Resources Board passing opacity results of 30% or less are a good indicator of a properly running engine. It is important to note that if there is an engine outputting over 30% opacity, this would be considered a gross emissions polluting application. It is also important to be aware that many engine issues are not detectable unless done in a very sophisticated lab. But we will discuss this in more detail in later slides. What we are trying to point out is that it is very difficult and important to verify the excellent condition of the engine and to determine which DPF model is the best candidate to create one efficient system that will function correctly through the daily operation of your diesel engine. There are typically 3 types of maintenance practices: proactive, preventative, and reactive. Most fleets operate with a combination of all 3 practices. Proactive is the top choice as it predicts when problems will occur and gives the fleet owner the most life of all engine and diesel particulate filter components, in addition to avoiding unscheduled downtime. Preventative maintenance consists of scheduled downtime. However, components such as oil, air, and fuel filters may not be used to their fullest potential as they are changed on a set schedule that is based on hours, miles, or days. Reactive is generally the last choice for maintenance practice. Using reactive maintenance, all downtime would be unscheduled as components are replaced or repaired at the time of damage or failure. It is important to discuss the types of standard maintenance practices to determine which type of maintenance your fleet performs. There are various ways to approach DPF and engine maintenance that works best for your current way of doing business. For example, if you are primarily performing reactive maintenance, you would want to make sure that you are operating a diesel particulate filter that has a high tolerance for catastrophic failure. DPF cores are very expensive and can be extremely sensitive to engine issues. A leaking fuel injector can cause permanent and irreversible damage to a cordierite material core, whereas a silicon carbide core is nearly indestructible. Keeping that in mind, the silicon carbide core may also have a higher upfront cost. Regardless of the type of maintenance practices you perform, there are many engine issues that are extremely difficult to detect, and may only be possible to do so in a sophisticated lab environment or with use of a dynamometer. Some of the examples are fuel injectors, valve wear or adjustment, turbocharger boost pressure, or piston ring wear. Even if you use engine ECU software such as Caterpillar Electronic Technician or Cummins Insight, you may still not be capable of detecting some of these issues. Let's consider a bad fuel injector to discuss this further. Some of the common ways to detect a bad fuel injector are by monitoring the exhaust temperature of each exhaust manifold while the engine is operating, or by performing a cylinder cutout test. However, this is usually completed at engine idle speeds. That is, unless you are fortunate enough to have access to a dynamometer to test at full load rated speed or other specific speed load points. Fuel injectors may not display a problem until the engine is operating at high load conditions. This is especially true for engines with a high pressure common rail injection system. A bad fuel injector may also simply have a seating problem that allows fuel to drip into the combustion chamber while the engine is off. This would lead to high smoke at startup. However, with a DPF installed, black smoke is no longer visible and there is no way to detect this. It is also important to note that for high-pressure common rail engines, many times when the fuel injector begins to go bad, it leads to overfueling. This overfueling will actually increase the engine horsepower, so you will rarely hear a complaint from the vehicle operator. I would also like to add that it is possible for a bad fuel injector to pass a dyno test as well. Generally, the dyno operator will run the engine up to full load rated speed and verify that the engine is producing the correct horsepower. On a chassis dyno, the dyno allows for plus or minus 10% the engine's maximum horsepower. Plus or minus 10% is far too great to determine the performance of a component as sensitive as a fuel injector. A bad fuel injector may produce a bad spray pattern, yet supply the correct amount of fuel. This may allow the engine to make the correct horsepower, but output more tailpipe emissions than a properly operating fuel injector. The only true way to determine if a fuel injector is operating is by testing on a flow bench, which unfortunately generally will cost as much as simply replacing the fuel injector. It is important to point out the challenges in testing various engine components. For some of these components, it may make more sense to simply replace the components within your current PM schedule rather than spend time and money to test them. Most engine manufacturers have recommended change intervals for engine components, such as the fuel injectors we mentioned above. Before the installation of your DPF, some of these replacement items were probably not a major concern, at least until the engine became a gross polluter or began to lose power. But again, we have to keep in mind that changes in tailpipe emission occur much before the point of power loss. Now I would like to talk about engine tailpipe emission sensitivity and the difficulties that engine manufacturers have had in meeting the continually increasing ARB and EPA standards. When we look at a 2005 on-highway heavy-duty diesel engine as an example, the regulation for soot is 0.1 grams per horsepower hour, and the regulation for NOx is 2.5 grams per horsepower hour. In order for the engine manufacturers to meet these incredibly low emission standards, required the introduction of various technologies. Some of these technologies include EGR valves to control the combustion temperature, multiple fuel injections per piston stroke, extreme high fuel pressures to accommodate those multiple injections per stroke, various ways to atomize fuel, variable geometry turbochargers to maintain the correct intake manifold pressure, wastegating the optimal amount of exhaust gas, and the list goes on. The recipe that these engine manufacturers have introduced pushes the engine to the very limit of the least amount of emissions the engine can possibly produce without having a DPF. What we want you to understand is that any microscopic change of your engine that affects the combustion chamber can easily double or even triple the extreme low emissions that the engine is producing, as they are so small already. I would like to spend a little more time on this subject to make sure everyone understands engine tailpipe emission sensitivity. I have seen many examples of engine complaints of power loss and also the test results that followed from those complaints. Many cases have shown that by the time the vehicle operator makes a complaint of power loss, the engine opacity results can be between 40 and 60%. This is an extreme gross engine polluter when you compare this to a like-new engine producing approximately 5% opacity. Now, if we assume that the engine, when in like-new conditions, is producing 0.1 grams per horsepower hour soot, which is the EPA regulation for 1994 to 2006 diesel engines, then by making some generalizations and interpolating to the 60% opacity result, we can assume this gross polluting engine is producing 1.2 grams per horsepower hour soot. This is 12 times the limit for most DPF models. Many of these engine power issues arise from worn components. We must keep in mind that wear takes place over a long period of time. By the time the soot output reached 12 times over the DPF limit, it must have passed through 11 times, 10 times, 9 times, etc. All the while, the DPF would have suffered from poor performance. The point I am trying to make is that it is important to not wait to perform engine service or repair until the engine is suffering severe problems. As we mentioned previously in this presentation, many DPF models are extremely sensitive to catastrophic failure and are also extremely expensive to replace. This slide is an example of an engine maintenance schedule for Cummins C, ISC, and ISL series engines. There are many reasons that I recommend the DPF end user follow the engine manufacturer recommended maintenance schedule. First of all, almost all DPF manufacturers will require that the DPF end user comply with all engine OEM requirements. If there were a DPF warranty claim submitted to the DPF manufacturer, the DPF manufacturer will require proof that the required engine services were performed. Second, the engine manufacturer has determined the optimal time to service the engine components through years of field and lab testing. The guidelines they put forth are good estimates for you to base your PM schedule. However, it is also important to note that if you operate under harsh conditions, you may want to increase the service interval even compared to the OEM recommendations, or consider using other proactive methods. Some of the service items I would like to point out are inspection of the air intake system, charge air cooler, and even items that may seem simple and insignificant but can have drastic effects on emissions, such as air cleaner restriction. Another important item is adjusting valve lash. You can see that for the C series engines, the valve lash is required very frequently of every 1 year, 24,000 miles, or 1,000 hours for the first interval. For the ISM and ISL, it is required at a much lower frequency. We highly recommend that you incorporate the maintenance schedule for each engine model contained in your fleet into your existing PM schedule. Equally as important as performing proper engine maintenance is keeping excellent records of the services or repairs you have performed. You have probably experienced an issue where you had a DPF service and the emissions technician told you something like, "Your engine is not running properly and you will need to fix your engine." Whether or not the engine is the root cause of the problem, it is important to know that the DPF will put the burden of proof of engine maintenance and keeping the engine running in like-new conditions on the end user. You may find this information in the warranty obligations in your DPF owner's manual. Being able to access and provide the emissions technician or DPF manufacturer with these records will take the liability off of the end user and back to the DPF manufacturer. Most importantly, these records will speed up the warranty process tremendously and put the DPF end user in a very solid position for warranty approval. Another aspect of proper record keeping is for DPF trend analysis, which actually can help with engine trend analysis. Both of these items are crucial in determining trends for common part failures, DPF cleaning schedules, and engine maintenance item adjustment. For example, not all DPFs will be able to go 1 year between filter cleanings as indicated in the DPF owner's manual. In fact, if you refer to your DPF owner's manual, it will generally read something similar to, "The DPF will go up to 1 year between soot and ash cleaning." Many factors will dictate this cleaning interval. Not all of these reasons will relate to engine maintenance. DPF to engine exhaust flow sizing plays an important factor in addition to the vehicle's duty cycle. By keeping proper records of all of your DPF cleanings, you may find that over a 2-year period, your DPF was cleaned 4 times. In fact, it was being cleaned every 6 months. This equates to twice the generic recommended cleaning interval. Having this trended data will give you the tools to work in a 6-month cleaning interval for the specific vehicle and avoid costly unscheduled downtime or expedited DPF cleaning from your local cleaning facility. If you are managing a fleet of 500 vehicles, without these records, you may have simply assumed that you had a serious problem with the DPF, when in fact you simply needed to adjust your cleaning schedule to match the duty cycle and sizing for the application. Another example where DPF trend analysis comes into play is when you see a sudden drop in the amount of time between filter cleanings. If you were consistently going 6 months between DPF cleanings for 2 years, but now your DPF is only making it 2 months, this would be a good indicator that you have another issue going on with the DPF or engine. In these cases, it is usually best to start with the engine. 9 out of 10 DPF issues are actually the result of a poor performing engine. Some frequent DPF component failures that we see are back pressure sensors and fuel filters. Once again, trend analysis helps in determining the root cause of the problem. If a back pressure sensor has been used for 5 years and just now fails, it may have simply used up all of its useful life. However, if your maintenance records indicate that you have been replacing back pressure sensors every 3 months, this may be a good indicator that it is installed in a high condensation area, damaging the back pressure sensor. The same mentality can be used for the fuel filter example. If trend analysis indicates that the fuel filters are being replaced very frequently, it may indicate that the fuel pickup location has dirt or other foreign material entry. We understand that in the current state of the economy, your facility may be suffering from a lack of resources to work towards the proactive type of maintenance that we would all like to have the ability to complete. There are many factors that impact the ability to do this, such as a shortage of qualified technicians, tools and software to perform proper diagnostic or repairs, a shortage in the budget, and the immense amount of training required for your shop technicians or operators to accurately service and operate the engine and DPF. Therefore, we understand that there will have to be trade-offs between what you can and have the ability to service and what you can financially afford to complete. That being said, it is important to understand that many DPF services can and really should be performed when your vehicle is undergoing its common A, B, C, or D PM schedule. This can save much time and money. You may also have to determine which services are most important and less important. As I mentioned earlier, if you are operating a DPF with a silicon carbide core, permanent damage to the core is almost impossible. With these applications, you may be able to choose to do less costly engine service while completing more DPF service. This is simply because the DPF can handle higher soot loading and other emissions constituents that other DPF cores may not be able to do. What we are trying to point out is that it is possible to operate an efficient fleet with minimal downtime, even on a shoestring budget, or due to other factors that will mesh well with your current business practices. In closing, we would like to spend a minute to let you know the services that Emissions Services Unlimited Incorporated can offer your company. From the higher level of work we perform, we can evaluate and audit your entire fleet and current maintenance practices with a goal of reducing your unscheduled downtime and reducing maintenance costs, which ultimately will increase your profits. In this evaluation, we will look at the current DPF maintenance you are completing to offer any additions or reductions. We will also look at your engine maintenance practices to make additions or reductions as well. As I have mentioned many times in this presentation, there are many services that can be completed at the same time between the engine and the DPF. For example, when cleaning a DPF, Emissions Services Unlimited highly recommends completing opacity and other engine diagnostics. The official opacity results tested at the DPF service could be used for ARB annual opacity reporting. We will also review the duty cycle versus the application as compared to the installed DPF. I know many of you are probably thinking that the vehicle you have in mind operates on a duty cycle that cannot be changed. However, there are many other ways to deal with a troublesome duty cycle. For example, we could reprogram the engine control module to increase or decrease horsepower to achieve the exhaust temperatures we are looking for. We may also be able to adjust the transmission programming to avoid engine speed load points that produce high amounts of soot. Emission Services Unlimited offers an endless list of DPF on-site services. We can service most manufacturer brands and models, such as Clear, Donaldson, Johnson Matthey, Engine Control Systems, Hoos, Hoog, and various others. We can also diagnose almost all engine manufacturers through conventional methods and using the appropriate software, such as Caterpillar Electronic Technician, Cummins Insight, Volvo VCADS, International Service Max, and many others. We can perform all of the various types of services we discussed previously: preventative, proactive, and reactive. In addition, we hold more certifications than any of our competitors in DPF and engine dealer certification, opacity, oil and fuel analysis, product liability, and many more. We also have more diagnostic equipment on our service trucks than any of our competitors. All of the work we perform for you will be overseen directly by one of our engineers. In fact, we are so confident in our work that we guarantee all of our work. If we service your vehicle and there is an issue immediately after, we will service that truck again for you free of charge. In closing, I would like to thank you for watching this video, and we look forward to becoming a partner in your emissions needs.